So we are going to discuss about EIGRP. It's a very important routing protocol. EIGRP. Most of the companies nowadays using EIGRP routing protocol in their company. EIGRP stands for Enhanced Interior Gateway Routing Protocol. EIGRP stands for Enhanced Interior Gateway Routing Protocol. It's a Cisco proprietary routing protocol, but from before 2013, it's Cisco only. EIGRP is using for Cisco routers only. But we know that in every company they are not only using Cisco system, because Cisco is expensive. So some companies will try another brand. So if we mix with Cisco and other router, it will not work. So mostly maybe they will not use Cisco routers. So in that situation, Cisco changed this EIGRP as an open standard. Every company can use. So now in current days, EIGRP is an open standard routing protocol. EIGRP is a hybrid routing protocol. Sometimes it's called advanced distance vector. It has a characteristics of both the distance vector and link state protocols. It uses dual algorithm to select the best path, or we can call that diffusing update algorithm. It uses reliable transport protocol to communicate with neighbors. EIGRP uses multicast for routing updates. EIGRP supports both IP4 and IP6 routed protocols. EIGRP includes subnet mask information in routing updates. EIGRP supports route summarization and discontinuous networks. While I am saying subnet mask, I have a small information to you. Some people they don't know what is the difference between subnet. What is the difference between subnet and VLAN? Actually, subnet and VLAN is same. VLAN is we are using for separating network, like we are creating different networks in a switch. That means VLAN is related with the switching, but the subnetting is related with the routing and router. Okay. If a PC which we are using in a company, that we are using in that PC subnet, that PC IP is in a class C subnet or in any subnet, and another PC that is accounts department, that is IP and subnet is different for that PC. Same like that, these two PCs should be in the different VLAN. So if a PC in a different subnet, that must be in a different VLAN. So nearly same, but VLAN is related with the router. VLAN is related with the switch, and the subnet is related with router. Okay, don't forget that. Most of the people they have still confusion about that, VLAN and subnet. Okay, subnetting and VLAN both we used for separating networks. Okay, let's come to our point. EIGRP supports route summarization and discontinuous networks. EIGRP protocol supports VLSM and CIDR. EIGRP protocol supports trigger updates. It sends partial or full update on only when something is changed in network. Default internal administrative distance of EIGRP is 90. Administrative distance is 90 for EIGRP for internal administrative distance. Default external administrative distance AD value of EIGRP external is 170. The default hop count of the EIGRP is 100, but we can increase that maximum 250 by changing the value. But by default the value should be 100. It maximum supports 255 hops. Also, EIGRP supports equal cost load and unequal cost load balancing. This is the only protocol which supports equal cost load and unequal cost load balancing. Eigrp take load balancing by default up to 4 paths can configure up to 32. Hello time of Eigrp is 5 seconds and dead time interval is 15 seconds. That means every 5 seconds Eigrp sends hello message for neighboring routers, and Eigrp takes 15 seconds to find a neighbor router is dead or any inactivity is showing from the neighbor router. It will wait for 15 seconds. That means the dead timer is 15 seconds. Eigrp updates are sent to 224.0.0.10 as multicast address. In interview, we may ask like a question: what is the Eigrp updates multicast address? So the answer is 224.0.0.10. Eigrp support MD5 authentication. It's an encryption method, MD5. By default, auto summarization is enabled in Eigrp. Eigrp maintains 3 tables. One table neighboring table, another one, second one topology table, third one routing table. Neighbor table include all neighboring routers that is directly connected to router using Eigrp. In simple words, next hop router and interfaces. That means a router which is connected directly to the neighboring routers. That all neighboring routers details should be in the neighboring table, we can see. The second table is topology table. Eigrp uses these tables to store all routes which is learned from neighbors. It contained a list of all destinations and routes advertised by neighboring routers. The Eigrp topology table contains everything the Eigrp has learned. Third table is routing table. Eigrp stores single best route for each destination in this table. A router uses this table to forward the packet. There is a separate routing table for each routed protocol. See, we can see here. This is an example for Eigrp neighbor table explanation. See, address, interface. These two are the connected neighbors of this router, and the AS number is 1. This example for Eigrp neighboring table. See, there are only 2 routers are connected. Okay, we have the explanation for all that. Address, the IP address of the neighbors is called mentioned here, address. Interface, the interface of the local router on which this hello packet was received. Hold, the amount of time left before neighbor is considered in down status. Uptime, how long the neighbor has been up. This SRTT stands for smooth round trip time, the number of milliseconds it takes to send an Eigrp packet to neighbor and receive an acknowledgement packet back. RTO, retransmission timeout. If a multicast has failed, then a unicast is sent to that particular router. The RTO is the time in milliseconds that the router waits for an acknowledgement of that unicast. QCNT shows the number of queued Eigrp packets. It is usually 0. Sequence number of the last update Eigrp packet received. Then we can check the topology table. This is the example for topology table. Okay, so you can just read this one. It's easy to understand. Then next table is routing table. See, these are the important things we have to check. Routing table. This is the routing way which mentioned C for D. See, this is D, so we can see here D. So there is the way for routing. Then what is Eigrp metric? Eigrp uses metric to select the best route from all available routes for destination. Metric has 5 components. 1. Bandwidth. 2nd. Load. 3rd. Delay. 4th. Reliability. And 5th. MTU. These only bandwidth and delay are by defaultly enabled. So what is bandwidth? Eigrp picks lowest bandwidth from all outgoing interfaces of route to the destination network. Bandwidth is the amount of data that can be transmitted in a fixed amount of time. Second one is load. Load is a dynamic value that changes frequently. It is based on packet rate and bandwidth of interface. It calculates the volume of traffic passing through the interface in comparison of maximum capacity. It is expressed on a scale of 255, where 1 represents that an interface is empty and 255 represents that an interface is fully utilized. Since data flows from both directions, router maintains 2 separate metric counters: TX load for outgoing traffic and RX load for incoming traffic. Next is delay. Delay reflects the time taken by a packet in crossing the interface. It is measured in fractions of seconds. Reliability. Just like load, reliability is also a dynamic value. It compares all successfully received frames against all received frames. 100% reliability indicates that all the frames which we received were good. We do not have any issue with the physical link. If we have any issue with the physical link, this value will be decreased. MTU. MTU stands for maximum transmission unit. It is advertised with the routing update, but it does not actively participate in metric calculations.